Okay, so the recording has started. Good morning, everyone, and welcome back to Math 115. What we're going to do today is basically we're going to try to get through all of A.6 because I need to start speeding up a little bit. So I guess this part of the course is still kind of review. So I'm not sure that I can spend quite as much time going through everything in a super rigorous way. So what I'm going to need to do is probably punt some of that rigor to the office hours. Okay, so I'm going to give you mostly just, excuse me, a little bit of exposure in class, and then you'll check out the homework. If it's not familiar, I need you to contact me and either set up an appointment or come to office hours. So speaking of, well, actually, let me cover homework first. So you have a homework due this Thursday on A.4. We finished A.4 yesterday, so you got today and tomorrow to finish that up. The next assessment is going to be Quiz 2, which will be on September 8th. I think that's a Thursday. That's next Thursday, I think. So what, like a week from tomorrow, right? Okay, so that'll be the next quiz. And now we need to talk about office hours. So I would want to initiate a vote in class here. So there are three options. So the first option is to keep the office hours as they are, which is Monday, Wednesday from 10 to 11:30. The second option is to move them to the afternoon on Tuesday and Thursday. So that would be from 2:30 to 4. It seems like that works better for people's schedule. But the last option is, of course, to mix those two. I could do something like one day I would do it in the morning, and then on Thursday in the afternoon. So those are the options. If we pick the last one, then I guess we'll vote on which morning we want to do. Doesn't really matter to me. Okay, so let's start the vote. So who wants office hours to stay? Raise your hand nice and high. It's not a single person. Okay. Who wants office hours in the afternoon? Raise your hand, please. Okay, I think that is going to eliminate the mixed. Who wants mixed? Okay, sorry. You've been voted off the island. We're doing afternoon on Tuesday and Thursday. Okay, so that will be effective Tuesday, whatever Tuesday of next week is. Let's check. So Tuesday of next week will be the 6th. So effective Tuesday, September 6th, my office hours will be from 2:30 to 4 on Tuesday and Thursday, and they will be in person in LeConte. And I think my office is 439. I don't actually remember. But it's somewhere on the 4th floor. I'll double check that for next time. Okay. Cool. So that should be a lot better for all of you so that you can come to office hours. So it seems like a lot of you had conflicts. So does anyone have an administrative question before we start on content for today? Okay, if not, then let's start on A.6. So what is A.6 all about? A.6 is about equations. So we're going to talk about essentially basic algebra. So solving equations, which are linear equations or quadratic equations or rational equations. Hang on, let me mark you present, Chris. Oh, you're at the top. Okay, so we're going to talk all about equations. So the first and most basic type of equation to talk about is, well, why don't we talk about what an equation is? Okay, well, an equation is basically a statement with an equal sign. Okay. So if I just write something like what we had on the quiz, x squared, what was the first problem on the quiz? X squared minus 9x plus 20. Then this is what we call an expression. Okay, this is what we call an expression. This is a quadratic expression. It becomes a quadratic equation when we add equals to 0. Now it's a quadratic equation. So I had a lot of people on the quiz factor this correctly as x minus 4 and then x minus 5. But on the quiz there was no equals to 0. So all I asked for was for you to factor the expression. But a lot of students wrote then, therefore x is equal to 4 and x is equal to 5, which I just crossed out. I didn't take any points off. But the reason that I crossed it out is because this is only true in the context of saying, well, in the context of equating this to 0. If I equate it to 0, then I have a product of two things, and it's equal to 0. So then it would be equal to 0, and therefore x needs to be either 4 or 5 in order to make the equation satisfied, right? But if I'm just factoring an expression, there's no equals to 0. There's no, this statement here is kind of not needed. How about that? Okay, so that's a difference between an equation and an expression. So the first type of equation we're going to talk about is a linear equation. And of course, I'm going to do this in kind of an abstract form. So we're going to take a and b to be real numbers, and at least a should not be 0 in order for this equation to be linear. Okay, so this number needs to not be 0. Why does it need to not be 0? Because if it was 0, then this term would go away, and we would just have b equals 0, which doesn't make sense unless b is also 0. So that's why we need a to be non-zero. So in this equation, I want to also point out that two of these letters represent a fixed number, okay? A fixed number. Those are b and a. Okay, are a fixed number, and x here is the variable. Okay, x here is the variable. So this linear equation is easily solved. How do we solve something like ax plus b equals 0? We subtract b from both sides, and we get ax equals b. And we're trying to get negative b. And we're trying to get x by itself, so we divide both sides by a. And then we get x is equal to negative b over a. Okay. Very simple stuff. Any questions on solving linear equations or on identifying linear equations? All right, let's make it more complicated then. Quadratic equations. Okay, we already talked about quadratic expressions. Now we're adding an equals sign. Okay, so we talk about ax squared plus bx plus c is equal to 0. So we can solve it in two different ways. The first way is to use factoring. So factoring, let's go back to our example. X squared minus 9x minus 20 equals 0. Then we get x minus 4 times x minus 5 is equal to 0. We factored. And now we use the zero product property, which said if I take two numbers and I multiply them and get 0, then at least one of those numbers is 0. That is how we are able to then establish two new equations, namely x minus 4 equals 0 or x minus 5 equals 0. And if x minus 4 is equal to 0, then x should be equal to 4 or x should be equal to 5. So that is the method of factoring to solve a quadratic equation. Okay. So those of you on the quiz that wrote this stuff, you just got a little bit ahead of yourself. That's okay. So let's talk now about the quadratic formula. We already wrote it down during another class. It's x equals all of this stuff. So let me just move that over a little bit. So how would I use this to solve x squared minus 9x plus 20? Well, I would first identify a, b, and c. What is a in this case? 1. Very good. We don't write 1, but there is, you can think about there being a 1 here. All right, and b is negative 9, and c is 20. So the way we use the quadratic formula is anywhere I see a b, I'm going to put a b, and anywhere I see an a, I'm going to put an a, and anywhere I see a c, I'm going to put a c. So we get Negative negative 9 is just regular 9. Then we get plus or minus the square root. Oops. We get plus or minus the square root of b squared is 81 minus 4, oh yeah, this is fine. Minus, sorry, 4ac, right? Which is going to be 4 times 1 times 20. 4 times 1 times 20 is 80, right? And then we divide that all by 2a, which is 2 times 1. So what do we get? We get 9 plus or minus the square root of 1, which is just 1 over 2, which is going to give us 10 over 2, which is 5. Or it's going to give us, when we subtract 1 from 9, that would give us 8 over 2, which would be 4. Okay, so 2 methods to solve quadratic equations. Any questions on either of these 2 methods? Okay, let's have some thumbs. How do we feel about the 2 methods of solving quadratic equations? Thumbs up if you're feeling great, and thumbs down if not so much. Hold them nice and high for me, please. Nice and high so I can see them all. Somewhere in the middle if you're somewhere in the middle. Okay. That's looking pretty good, so I'm going to move on. Okay, let's try one with a partner. Let's use 2 different methods. So actually, yeah, okay. Let's use both methods for the same one. Okay, so try with a partner. We're going to solve this quadratic equation first using factoring and then using the quadratic formula. And I'm not going to leave the quadratic formula on the screen because it needs to be memorized at some point. So, all right, work with a partner. If you have questions, I'll be walking around. Lost him. Mia?
I think you have the sound on.
All right, how are we feeling? Do we need a little more time to work? Okay, I don't see any hands raised, so I guess that means we can go through it together. I guess this one's pretty easy, isn't it? Well, okay, let's try the factoring method. I need 2 numbers which multiply together to get -3 and add together to get 2. What are they? It's -1 and positive 3, right? Okay, if I have two numbers and I multiply them together and get 0, what must be true? One of those numbers must be 0, right? Which is why, therefore, x is equal to 1 or x is equal to negative 3. Okay, let's use the quadratic formula. What is A here? 1. What is B here? 2. And C is negative 3. Okay, so one mistake that you can fall into here is thinking that C might be 3 because I see a 3 here. But you got to remember that all of these numbers have a sign. Okay, so we need to keep that sign. Okay, so x is equal to negative b, that's negative 2, plus or minus the square root. And what goes under the square root? B squared minus 4ac, right? So b squared is 4 minus 4 times 1 times negative 3 is negative 12, right? So we get a plus plus here. Okay, so this is all being divided, of course, by 2, right? So what do we get? This is negative 2 plus or minus the square root of 16, which is 4, all divided by 2. Okay, let's start by adding 4. If we add 4, then we would get positive 2 over 2, which would be 1. If we subtract 4, we would get negative 6 over 2, which would be negative 3. All right, how do we feel about this example? Pretty good? All right, I think this should be one of the topics from the review that is most familiar. At least that's what I would expect. Okay, let's see a new type of equation, a rational equation. Okay, why do I call it rational? Well, remember, rational, the first part of the word rational is ratio, which means fraction, which means this is going to be an equation involving fractions or rational expressions, right? So we've got 1/6 plus 1 over x plus 1 equals 1 over x. So the trick to solving an equation like this, okay, is since we can't manipulate the denominators very easily, we're just going to get rid of all of the denominators. We have this handy equals sign here, which allows us to change the left-hand side as long as we change the right-hand side in the same way, okay? So this is not like rational expressions before where we had to make sure we were always multiplying by 1. Now we can multiply by something else as long as we balance the equation on the opposite side. So in this case, I'm going to multiply by the least common denominator, okay? So the way we find the least common denominator is by looking at all three denominators here and looking at the missing factors from all of them in order to get the smallest denominator that would be able to eliminate all of these denominators when multiplied. So in this case, LCD is going to be 6 times x plus 1 times x because these three denominators do not share any factors. Okay, if I do it like so, I'm going to multiply on the left and right by this number. So 6 times x plus 1 times x. I'm going to multiply that times 1/6 plus 1 over x plus 1. And also, I'm going to put the bracket all the way on the right-hand side to show that I'm also going to multiply it times 1 over x. So what do I get when I multiply 6x plus 1 times x? And I multiply that with 1 over 6. I get the 6's cancel, right? And I'm left with x plus 1 times x. And then plus, what cancels for the second one? The x plus 1 is going to cancel. I'll be left with 6x is equal to, what cancels for the last one is x. So I'll be left with 6x plus 1. Well, 6 times x plus 1, sorry. Whoa. That was weird. Okay, we're still recording. All right. Okay, so now what do I do? Am I done? Yeah, we should multiply everything out and then combine like terms, right? So let's do that. We get x squared plus x plus 6x is equal to 6x plus 6. Now, I have a quadratic equation here. The way I solve a quadratic equation is always to move everything to one side. So we start with x squared plus x plus 6x minus 6x minus 6 is equal to 0. So I subtracted this from both sides. The 6x's cancel, and I'm left with x squared plus x minus 6 is equal to 0. Solve using the factoring method. X, I think minus 2 and then plus 3, right? And therefore x is equal to 2 or x is equal to 3. Okay, so I went through that kind of fast. Let me review what we did. We multiplied both sides by the least common denominator. That was in order to get all of this jazz to be not in the denominator, because it's really complicated to try to solve an equation where the unknown is in the denominator. So what do? We just take this hard problem and we turn it into an easier problem by taking all of these things and just multiplying by the least common denominator. That got everything into the upstairs where we like it. Then we simplified the upstairs a little bit and got a quadratic equation, and we used our previous methodology to solve that quadratic equation, except I did it wrong because this should be a -3, right? Yeah, please point that out if I make a mistake like that, because sometimes I'm like trying to talk and I'm also trying to write at the same time, but what I'm saying isn't the same as what I'm writing, and that messes me up. All right, any questions on this rational equation? All right. I'm making pretty good time here. We're probably going to have time to do more examples today. All right, so let's talk about a new type of equation. And that is equations with radicals. Okay, so equations with square roots or nth roots, where n could be larger than 2. Could be a cube root or a fourth root or something like that. Okay, so the trick with equations involving radicals is the following. What you might think initially is, well, I have a radical, so why don't I just get rid of the radical by squaring everything, right? Why don't I just square everything? But the problem is, if I were to just take this thing and square it, and then take this thing and square it, and then take this thing and square it, then I would be changing what this equation means. Can anyone tell me why doing something like this is not allowed? Why doing something like this is not allowed?
It's not allowed.
It's not allowed. Yeah.
Multiplying by the same value, you could be multiplying by like an exponent of 2 on one side and
Well, it is.
I'm sorry, a base of 2 on one side and like a base of 3 on the other.
It is doing something different on both sides. I'm looking for a little more specific explanation than that. Okay, well, let's see what I have on the left-hand side. I have essentially something which looks like a plus b. And here's a question for you. Is a plus b squared equal to a squared plus b squared? No. What else do I need in here? If I square a plus b, what do I need to do? I need to FOIL, right? This is a binomial expression. A plus b is squared is a plus b times a plus b, which I would need to FOIL. I would get a squared plus ab plus ba plus b squared, which is a squared plus 2ab plus b squared. So these two things are not the same, okay? Not the same. So in general, even though if I were to do something like 6 times a plus b, we can go ahead and distribute a multiplication. We can never, ever, ever, ever distribute a power over a sum like that, okay? So that is a big, big rule. So how am I going to handle this knowing that I can't just square everything? Well, you might naively think, well, I'll square the right-hand side, and I'll square the left-hand side, and I'll go ahead and do the FOIL, right? I'll do the FOIL. What will I get if I do the FOIL? I would get, of course, 2x plus 1, and then I would get plus 2 times the square root of 2x plus 1, and then I would get plus 1 is equal to x squared. And now it just feels like this is even worse than it was before, right? Because why? Because when I was foiling this guy, the multiplication of the 1 with the root gave us this term. If this term wasn't here, I would be happy, right? Because then I would just have a quadratic equation. So the problem is really stemming from the fact that we have this 1 here hanging out with our square root. Okay, so the trick we're going to use here, so that's the motivation for the trick. And the trick we're going to use is that we're going to just get rid of it. Move it over to the other side. Now we have square root 2x plus 1 is equal to x minus 1. Okay, so why is this better? This is better because when I square both sides, I'm not going to have any radicals anymore. I'm not going to have any radicals anymore when I square both sides here. So let's go ahead and do that. So I'm going to take both sides and square. What do I get on the left-hand side? If I take a square root of something and I square it, then those two cancel, and I'm left with whatever was under the square root to begin with, which is 2x plus 1. Am I using a different color here? What color was I using before? Was it this? Oh, it was that. Oh well. I like the other orange better, actually. Okay, 2x plus 1. How about the right-hand side? What do you think about x squared minus 1 squared, right? Did I do that right? No, what did I fail to account for? The foiling, right? In other words, the middle term. What do I get when I do x minus 1 squared? I get x squared minus 2x from the middle, and then plus 1, right? All right, so I'm done, right? Still have to actually solve this equation, right? Okay, but it's going to be a lot easier because now it's just quadratic, right? So let's get everything onto one side. I'm going to subtract 2x, and I'm going to subtract 1 from both sides, and I'm going to get x squared minus 2x plus 1, and I'm going to subtract 2x, and I'm going to subtract 1, and then the other side is going to be 0. So don't be confused here. All I did was I moved this side to that side. The only reason I did that is because I like having the equals 0 on the right-hand side. All right, so now we combine like terms. We've got x squared minus 4x is equal to 0, right? Because the plus 1 and the minus 1 cancel. All right, so if I have x squared minus 4x is equal to 0, how do I factor this equation? X plus 2 times x minus 2? Do we agree with that? I'm hearing no. Who says no, and can you explain why?
You're leaving out the x, but that's with the negative 4x.
Yeah, this is what we would get if we had x squared minus 4 with no x here. But we do have an x there. So how do I factor something like this, Connor? Yeah. The first thing we do every time we factor is always first to take out a GCF, okay? Take out a GCF, which in this case we can take out a GCF of x. What am I left with inside if I take that out? X minus 4 is equal to 0. And now I can go ahead and use the zero product property, right? I have two things being multiplied together and I got 0. That means one of them must be 0. Therefore, either x is equal to 0 or x is equal to whatever would make the second thing 0. What's that number? 4. Not negative 4, right? Okay. So that's how we handle equations with radicals. Any questions on this particular equation? No? Okay. I think that so far, the equations with radicals and the rational equations are the hardest. Do we agree with that? Yeah, so those are the tricky ones. When you get to the homework, I would say that those would be the ones that I would focus on for studying. Okay. So let's go to equations which are quadratic in form. Okay, so this is, in my opinion, one of the harder topics in this equations section. So, what are equations which are quadratic in form? Well, quadratic in form as opposed to just regular quadratic. So we know regular quadratics look like ax squared plus bx plus c is equal to 0. So what do we mean when we say quadratic in form? Well, what we mean, okay, is that the equation can be rewritten as a quadratic equation where u is an expression involving x. Okay, so how do we identify an equation which is quadratic in form? Well, the way we identify an equation which is quadratic in form is we look at the powers of x here. And you can see that there's a pattern in the sense that the middle term has half as many powers as the first term, and then the last term has no powers, right? The last term has no powers. So I'm going to go real slow on rewriting this. Okay, I'm going to do this in the following way. If I were to set u to be x squared, then you would agree with me that u squared would be equal to what? X to the fourth power, right? X to the fourth power. Because I take x squared and square it. So x squared times x squared would be x to the fourth, because we would add those powers. So we get x to the fourth. Then I can rewrite this, right? I can rewrite this using this change of variables. That's sometimes what we call it. Change of variables. I'm going to move that down. So change of variables. So we use this here to rewrite. So where I see an x to the fourth, I'm going to rewrite it as u squared, okay? Because u squared is equal to x to the fourth. So I get u squared plus 2 x squared is what u is, right? So I'm going to get 2u, and then plus 1 is equal to 0. Okay, so now I have an equation in terms of u, which is a quadratic equation. So I rewrote a equation with power 4 as an equation with power 2, where u is equal to x squared. So now I can solve this for u using any method that I want. Like, for example, factoring. This factors as u plus 1 times u plus 1 is equal to 0, right? And therefore, u should be equal to 1, right? Negative 1, sorry. U should be equal to negative 1. Ooh, there's a problem here, isn't there? Okay, so therefore u should be equal to negative 1. Okay, so are we done? Are we done solving this equation? Right, so this is the values of u, which would solve this equation, which we've rewritten, right? But what we're supposed to find is all of the values of x that make this equation true up at the top. Oh, that's a little hard to see, isn't it? We want to make this equation true. We want to find the values of x such that if I plug them into this equation, I get 0. So I need to back substitute by my change of variables. So I need to reverse the change of variables. Well, I know that u is equal to negative 1 is equal to x squared, right? So if I want to find x, what should I do? How about take the square root on both sides? So I just get x is equal to the square root of, negative 1. So at this stage, you might be tempted to just circle this and be like, okay, well, I'm done. That's the answer, is x is the square root of negative 1. I found the answer, right? But in this case, we're only considering real numbers which solve this equation. We're only considering real numbers. So we're not talking about complex numbers in this class. So for this class, I would say there is no solution. Okay, why is that true? Because let's look at this equation and imagine. Imagine that I took a positive number. If I took a positive number and I take it to the 4th power, and then I take it to the 2nd power multiplied by 2, then all of this is going to be what? It's going to be something positive, right? If I take something positive and I add 1, can I get 0? No. What about if x was a negative number? Well, if I take a negative number to the 4th power, that's a positive. If I take a negative number to the 2nd power, that's a positive, right? So if x is positive or if x is negative, no matter what, this is going to be larger than 0. If I add 1 to something which is positive, there's no way I can get 0. Okay, the final case that I didn't consider is what if x is 0? Well, if x is 0, then we still have 1 equals 0, which isn't true, right? So that's why there's no real solution to this equation. Okay, so you could say no solution, or you could say, if you want, there's no real solution. But I'll take your meaning either way. Any questions on this one? Okay, raise your hand if you think this is the hardest one we've done today. Okay, so these quadratic informs are pretty tricky. Let's try one with a partner here. And this will be the last thing we do for today. So I'll come around and help you as needed, but we want to figure out a change of variable here that is going to help us solve this.
Are we using the same factor?
Same factors?
Not factor. Are we going to use the same thing as like
Nope, it's going to have to be different, right? Because we've got a 2/3 power and a 1/3 power. So let's see if we can figure out what that u should be, and then solve it with a partner, okay? And I'll come around and help.
Well, I think what they do is found out it's like so hard to, it's like I kind of get it, but like I don't
We get something like u squared
I just need to I need to look at this real quick and see if it just.
Does that make sense? So what we want to do is, what we'd like to do here is rewrite this somehow as u squared minus 7u plus 6 equals 0. Right? This is how we want to rewrite it. You can see that what needs to be true. These two have to equal one another, right? We replace this 2/3 by u squared. Needs to be true. X equals 0. So I want to know what should you do in order to make this change. What should you do? How can I solve this equation for you? Not a common denominator, but we want to get u by itself. Right now it's being squared. How can I undo the power of the two?
Wait, what if it's like?
I can take the square root, right? In other words, I can take the power of 1 half. If I take x to the 2/3 to the 1 half, what should I use? Multiply, right? So 2 times 1 is 2, and then 3 times 2 is 6. So we get over 6, which is 1/3. So we get that x to the power 1/3 is the same as u to the power of 1, right? So 2 times 1 half is 1. So now we figured out what u. So this is how we're going to rewrite now. X to the 2/3, that's u squared. X to the 1/3, that's u. And now we get this equation. So how do we solve this? Yeah, right. And then after that, we're going to use this to get back.
Do I want to change the variables? For example, where u squared was x to the 4th, so I set u squared.
Okay, I want to really quickly discuss this as a group, just so that I don't leave you all hanging. Okay? So the trick here is to recognize that what we want to do is rewrite this as u squared minus 7u plus 6 equals to 0. Right? This is how we want to rewrite. If this is true, if these two things are equivalent, then u squared and x to the 2/3 have to be equal to one another, right? And this can be used to figure out what u should be. Well, if u squared is equal to x to the 2/3, I can take both sides to the 1/2 power. In other words, take a square root on both sides, and I get u is equal to x. If I take these two powers, what do I do with them? Add or multiply? We should multiply them in this case. So we get 2/6, which is 1/3. So this is how I can figure out what u is going to be. All right, so this is going to be used to go backwards at the end. So now I just need to solve this quadratic expression, which can be solved using factoring, right? It's u minus 6 times u minus 1, right? Is equal to 0, and therefore u is equal to 6 or u is equal to 1. Am I done? No, the last step that I have to do is what? I need to reverse the change of variables. I heard it out there. Very good. So u equals 6. I need to say, well, if u is 6, what is x going to be, right? What is x going to be if u is 6? Well, I can solve it using the following. 6 is equal to x to the 1/3 power. So what should I do to get x by itself? Multiply? Not multiply. If I multiply on both sides, I would just get 1/3 times x to the 1/3. How do I undo a 1/3 power? By cubing. Very good. I cube both sides, I get 216 is equal to x. How about the other one? I get 1 is equal to x to the 1/3. Therefore, x is equal to what? Should be 1, right? If I cube both sides, 1 times 1 times 1. All right, that's it for today. Thanks for your attention. If you have questions over the quiz, then hang out after class.
Have a good day.
Yep, you too.
So I need to make it up during office hours?
Yeah, so office hours next week are going to be Tuesday and Thursday from 2:30 to 4.
Okay.
Does that work for you?
Yeah, I can do Tuesdays.
Okay. I'll be in my office in LeConte, hopefully, by then. But make sure, I'll send an email at some point saying whether or not office hours are going to be in LeConte versus online. And also, if you're in class on Monday, then I'll announce it verbally.